Welcome, conference attendees. I'd like to thank the organizers for this opportunity for Chao and I to share our work on the development of HanziFinder, a tool that allows one to search Chinese characters by substructure. This is our homepage of the current tool. We've had 3 iterations of our tool, and we're now on the third, well, that's obvious, third iteration. Many Chinese characters are considered to have 2 substructures, the radical and the phonetic. Oh, now it's not working. There we go. Okay. The radical is a substructure which contains meaning. The phonetic is alleged to contain no meaning, but does it? My research partner, Chao, and I have developed a tool that could help determine whether the phonetic, can you see my screen? You can see, people can see my screen,
yes,
right?
Yes.
Okay.
Yes.
Okay.
Yes.
Developed a tool that could help determine whether the phonetic component or any substructure of a Chinese Hanzi character influences meaning. I will give an overview of the HanziFinder tool and its potential uses. Chao will describe the creation of our current iteration of the tool and our intent to make the search engine accessible to researchers. Our HanziFinder tool searches a database of 88,884 characters. These characters have been redrawn into nodes and lines by 3 people, Meiqin Xia, Huimin Luo, and Wenqing Huang, over approximately a year. The team has turned raster Hanzi characters into searchable, decomposable stick and ball graph renderings. The red is the target structure. The blue outlines the rest of the character. The renderings of these nearly 90,000 characters can be searched by a structural query that is as small as 1 stroke or as large as an entire character, or anything between as defined by one node to node section as seen below. We have used a number of methods in order to validate that our tool is finding a large percentage of the characters containing a given substructure. We have data on the following, which I will share as soon as I'm done with this talk in the chat. And you can see, and we actually have more than this, but I'm just showing what was, anyway, we have more than this. Possible use cases: helping non-native users acquire and retain a target language by creating semantic probability maps of substructures. 当我52岁，我开始学习中文。When I was 52, I started studying Chinese. 现在我63岁 I am 63. 所以我知道这个方法真的帮我。特别记得了生词。This method has really helped me, especially remember vocabulary. Researching the weightedness of one substructure, a group of such substructures may have in driving meaning. Researching the pattern of bias and its relationship to structure, researching the relationship of structure to meaning. If we were to find every character containing nai, then compare meaning space for clusters, we begin to know if the phonetic, in this case, nai, confers, sorry, I'm struggling with this, confers meaning. And you can see that there's a lot of associations with pregnancy and even things that have association, fatigue, paralysis of the foot, blessings, happiness. These all have pregnancy associations. Nai has a strong correlation to procreation. This looks like birth. A child, Z, is coming out of the mother's body. Nai, the meaning is pregnant. The precursors resemble the enlarged body of a pregnant female mammal, and I have also studied Guaiji, ancient Egyptian, Sumer-Yu, Sumerian, Maya-Yu, Mayan. We see a constant consistency of pregnancy, milk, breast depicted with similar kinds of shapes. So the data breakdown: we have procreation, pregnant breast, baby milk, utilization, things to eat, use, enjoy, deprecation, negative or violent. And then we have a lot of undefined characters for a total of 282 characters, and really it's 286 if you look at the dual character, which sometimes has a nai component. The G changes into nai. Helping a new learner predict probability of meaning when seeing a substructure present in a Hanzi character, in this case nai, is one potential use of the HanziFinder tool. Finding every character with a particular substructure and sorting by meaning could create a semantic probability map such as this one. You see 49% procreation, deprecation 17%, utilization 34%. Here is a semantic probability map for Fan Chuanpong. This probability map could give clues as to whether or not the phonetic or any other substructures equate to meaningful elements. The map would then be based upon the clustering of meaning space. Yes, some of this is somewhat subjective, but a large amount of people would probably agree with these clusterings. So we have for Fan Chuanpong, beast, negative, human, and nature. And we do want to question that human component, especially when you consider Yotai, which is Jewish, has the Fan Chuanpong radical. We can use these lists to study the relationship between substructure and meaning. If other substructures besides the radical convey meaning, then there is an untapped area for research, as well as a new method for better language acquisition. Thank you for all you wonderful people and organizations and websites. It has been invaluable for us to do this work. And thank you for the Digital Orientalists Virtual Workshop and Conference, June 26, 2021, and to the organizers. And I will now hand this over to Chao. Thank you.
You're really fast.
I know, I'm trying to not take too much time because I figured people can watch it later and stop it. So,
okay, so Jennifer used this tool to have some fun, I guess. And I will focus more on how some fundamental ideals we use in the development when we do this project. Can I take this one? Jennifer has this idea of substructure searching on Chinese characters for like 10 years. And we started to work on this like 3.5 years ago. At that time, we did some research. We want to find we wondered whether there is such tool. And there was no. So we decided to make one by ourselves. There are 3 major versions. Each of them is highly dependent on how we look at, how we represent a Chinese character. In the first version, we represent a Chinese character as a sequence of stroke and use stroke information to do computation. In the second version, we use autoencoder to encode a raster image into a fixed size vector, so-called fingerprint vector. And we use that vector for substructure searching. In the current version, we turn a character into a graph like you just see. Graph is good for 2 reasons. First, graph is just a collection of nodes and edges. In a more general sense, it's objects plus relationships. Graph is much more compact than images. One easy example is like for image. If you want to have a sufficient resolution that still covers you can still recognize substructure. It has to be like we did, 100 by 100. That's 10,000 values. But for a graph, for this 9 character, it has 9 nodes and 8 edges. For each node, it only takes 2 numbers to describe the x and y coordinate. And for one edge, it takes 2 numbers, which is source and a target node index. So it only takes 34 numbers to represent all the information. It is way more compact. The other reason is these nodes and the edges, especially the edges, carries structural information much more directly than images. Nowadays, people use convolution blocks to extract local information, local features from images. But if you can define, you can use that directly. Why bother to use another block to extract? Once we have this graph representation for character, we can view the substructure searching problem as a subgraph searching problem. And this problem can be rephrased as a node selection process like this. Let's say this orange structure is our target structure. It has 9 nodes. And this blue collection of nodes is like a bag of possible nodes you can take. It takes 9, so there are 9 steps. At each step, you need to take 1 node out of this blue bag as candidates. So there are 17 to the power of 9 possibilities, which is 118 trillions. This is good because we know solution is there. This is terrible because the number is too large. It takes too long to validate all of them. So we developed several tricks to prune the decision tree. One is we don't want repeated nodes. The second is this polarization ideal. Let's say the gray one is our previous structure, the best fit. And we want to find something like this orange one. For this blue one, it's on the right, it's on the up. So it both hits on X and Y. This one is also because it hits on the Y axis, but not on the X. This one is opposite. So we can use this kind of geometrical relationship to describe the difference. The third idea is skeleton. Let's say this origin pattern has 3 connections here, and this blue candidate has only 2 hits. This one is missing here, so it has 2 of 3 hits. The last one is posture. It's kind of like 4 patterns have same skeleton, it's the same character, but different people have different styles. Posture captures such style features. For a trigonal here, there's 3 relative arrows here, from 1 to 2, 2 to 3, and 3 to 1. And for each of them, we can record a number for the angle, 0 to 65, you got it. And for the blue one, we can do a similar things. And we can do, we can calculate the difference row by row or edge by edge, and use these numbers to construct a difference for the posture. With these tricks, we developed the prototype version of our current tool. It works really amazingly. So with this what we did is we developed 3 versions of substructure searching. Stroke information is great, but it only covers 9,000 characters. We want to have a larger coverage for research purpose. So we have the second version, but it's a convolutional neural network, so it suffers from the interpolation issues. We cannot explain what those 64 numbers mean, and it's not reliable. That's why we have the third version, the graph representation. With these tools, they can be the building blocks for other Chinese research and the learning process. Jennifer did some very interesting cases. Talk to her; it's going to be fun. And you can use this tool to do other funny things. Use your imagination. We suffer from several problems for this graph representation idea. One is like this dot character. We find it's very hard to unify the rules to draw, like these 2 nodes is separated here. In some cases, people join them or separate them on this horizontal line rather than branch here. The other one is the current algorithm cannot tolerate the arrows in like have one extra node, extend it a little bit or missing one. These are problems we will to work on. For our future plans, we are looking for ways to protect our graph data before making it publicly accessible. It will be in the end, but we want to protect our work. The other thing is, during this process, we find it's really hard to make a consistent rules for label rejoin. And we met a lot of funder cases, so we want to unify and document, make some documents about this. And the third thing is, I try to deploy this searching algorithm with JavaScript onto browser, but it's too slow. It takes about 180 hours to do one search. It's a nightmare. We will release a C++ or Python version GUI client. The current version is written in Python with NumPy and NumPy. The website we have, HanziFinder.com, currently is based on the second idea, the vector idea. We think for the third version, it will be a kind of data center you can push and pull substructure searching results for your purpose. You want to share with other people. This is all I want to talk. Thank you all for having us. Thank you for our teammates for helping us building this tool, and the open source community for without them it's impossible. And thanks to Jennifer and her family. Without her, this is impossible. She is an amazing female. Yes. Do you have any questions?
Thank you. Did that search ever come up? We're searching a character. Where are we with that?
It's still running. It has only been 15 minutes. So it takes about 25.
Thank you very much. We can share it on chat, perhaps.
Yeah, I can share later.
Yes, please do that. Okay, so thank you for that. We are ready to take questions. We have a good 5 minutes, 7 minutes. If anyone has any, raise your hand, type it in the chat. I have a couple, but I don't want to take advantage of the fact that I'm running the show to always jump in. Yes, Willis Monroe. Sorry.
Hi, thank you. That was really fascinating. This is a question coming out of ignorance. I work in cuneiform, so I'm not very well versed with Chinese writing. But my understanding is that you, at the beginning, you showed that there is an element of compositionality to some of these signs. You can combine two of them, get another meaning. And I've been working on a project dealing with proto-Elamite, which is kind of adjacent to early cuneiform. And the nice thing there is it's undeciphered. So we have no preconceptions coming in. And we've been trying to figure out if there is compositionality there. But again, we have no idea going into it. So we have to sort of do a visual analysis and look for context, etc. So my question with the graph-based approach is that you really can start to, as you said, look at these substructures. Do you think that you might start to discover aspects of compositionality which are otherwise not known? So not necessarily two signs, but maybe two aspects of signs that can be added together that can equal something that people hadn't previously considered, right? Because of course it's a living language.
I want to first confirm that I understand the problem properly. And are you saying like what we are doing now is we establish these strokes with graph methods. It's kind of like have limited space or possible structures here, and you are curious about could it possible help define it when you are facing raster images to identify some structures like skeleton structures that's outside of the.
Yeah, I'm interested in whether or not there could be subsections of signs that could have meaning, right, that you haven't identified yet. So like a particular arm that is added to multiple characters that up till now people haven't recognized has any kind of inherent meaning, but through your subgraph analysis you can see that all of these things have similar context or something, right?
This is exactly our goal. This is exactly our and to be perfectly honest, this has come out of a research that I did helping our son go from the 44th percentile to the 89th percentile on those English tests because he was struggling. And I started looking at Greek and Latin root words and realized that there was a pattern based on bias and that we could be harnessing bias to understand language more quickly. I believe that female mammals are the underpinning of written language. And if you look at Sumerian, Egyptian, even linear B, you can see that the shape of V has meant female for 6,400 years. If you look at Denise Schmandt-Besserat's token data, she did a great deal of work showing that the Sumerian characters had relationships between, the token data has a relationship with Sumerian characters, and the token data is about 10,000 years old. You can see that a sheep is a circle with a plus, and EWE, female sheep, is a circle with a plus with a V. So that character is 6,400 years old. And we see this in Chinese and other languages, but I don't know.
Yeah, so I'm just putting at the title of a paper in the chat that we found very useful when we were trying to do this type of analysis of kind of sub aspects of graphs of characters. So you might find it useful. It's this OCS PCS score, which can be really useful for understanding the regularity of sub aspects of characters. So if you're interested, I highly encourage you to read that paper.
You put the paper in chat?
I put the title of the paper. Yeah, you can just Google search.
Wonderful, wonderful. I'll search it. Thank you very much.
Yep.
So we have a question from, thank you, Willis. We have a question from Tillman. He wrote it in the chat, but please give it voice too.
Okay, thank you. So this is, I think, a question in a similar direction, or even the idea that you described in the beginning of your talk. I wonder if you already found like some interesting meanings that lies hidden in the presumably phonetic component of the characters. So something that strikingly reappears in a certain semantic field. Can you talk a little bit about this?
We can look at this one page here. Let me see if I can get this up here. Am I still sharing my screen? I don't think so. Here, let's go here. Share screen. And this, share. If we look at this, start play from current slide. We can see that we have looked at this, what I call a B doppelganger. And if we look at the alphabet used to go A, B, V, G. So B and V have a very close association. I believe they're female mammals, breasts and vaginas. So if we look at here, we see be pregnant, to be pregnant, small. Well, women are smaller than men. Milk, women's breast, nurse, small fish, spawn roe, late. These are concerns when you're pregnant. Slow, thicker, fatigue, paralysis of the foot, blessings, happiness. What character has a relationship with fatigue, paralysis of the foot, and blessings, happiness, but pregnancy? And now people will question this, and this is where the subjective part comes in. Why is neon there? And you notice this is not a word we use anymore. Nihong is the word for neon now. We don't use this character. It has fallen out of favor. I believe it's because neon and lactating breasts are both enticing. It's not probably, I'm telling you things that I'm the messenger. Fill, overflowing, surplus, to accumulate, all of these could have relationships with pregnancy. To profit, well, we know prostitution is one of the oldest professions. Buttress, battlements, we have the word fortress, which has in Chinese has a strong association. I think it has 3 V's in it. Hide, avoid, superior, talented, you're very talented if you can produce babies. So there, I'm going, this, I'm sure is subjective and could be questioned by people, but I think it's so obvious. I mean, when you look across the board at all these written languages, it really is, I think, very obvious. Why wouldn't it be? Female mammals are we have milk, offspring, and fun for males. Sorry.
Thank you. So this you're also using this to do some cross-language research.
Yes.
Comparing different scripts. Okay, very fascinating.
I should tell you, I have a website, originofalphabet.com, and I have all of this data on, I'm sharing it now, originofalphabet.com. I have ancient Egyptian, Sumerian, many Latin, Greek, Hebrew. I've looked at a lot of languages over the last 12 years. Thank you.
Thank you.